Today we're talking about identity and zero trust. Zero trust appears like a new thing. It's been the flavour of the month for a while. Identity, well, you know, as of old, we've always been talking about identity. But the hybrid world and the way things are coming together actually makes a bit of a difference. So we'll be going through some of that. My name's David Guest. I'm a solution architect with ThirdSpace and technology evangelist. So I do quite a few of our webinar series and stand up and present quite a lot. And I'm going to be guiding you through this over the next 45 minutes, including the questions. Hopefully you'll enjoy it and you'll get something. We do have an agenda, which I will do my best to stick to. We're going to be looking at the key identity considerations in achieving this zero trust. How we can make sure that our users and applications are connected to Azure AD in terms of the security around that. How we can verify that identity in a hybrid world. So we'll be talking about MFA, passwordless. How we can improve the visibility of those identities and how they're actually being accessed and used. And because it's important, specifically with the zero trust, we're going to look at implementing least privilege, both in terms of the cloud versions, but also we'll talk about potentially what you'll need to do on premises to make that work as well. Now, it may have escaped your knowledge, but ThirdSpace and TIG have merged. We've become one more coherent unit, so we can do a much better job of maintaining people's infrastructure and environments, not just around identity, but also with artificial intelligence, machine learning, data lakes, data stores, SOC, so Security Operations Center, and everything else. The range of Microsoft partnership agreements that we have is now vast, and it should enable us to work much better with you to deliver what you want. So why are we having this zero trust conversation? It feels like a shift in the security strategy, and it feels like something that should have happened quite a long time ago. Well, let's think about what we're trying to do. We're trying to use some form of access control to keep the assets that we have away from the attackers, away from people who are interested in taking those assets away, whether that's information, intellectual property, could be identities even, because identities have a value. Now, IT security is very complex. We have all of our own internal users. We have those external users that we partner with who may have their own identity that they want to use, or we may be creating an identity for them in our environments so they can gain access. We have a number of connections that we can control or that we can't control. It's very difficult if you're using a cloud service to make sure that the cloud provider is actually doing the same thing that you do in terms of those connections. And we also have to now worry about lots of devices. I personally am surrounded by laptops. I have multiple screens, I have multiple mobile devices, I have multiple tablets. That plethora of devices is increasing, and there seems to be no stopping that rate of change. If we go back in time, we can look at the idea of a trusted network. The network was on premises, it was protected because, well, the office had a door. There was no connection to the internet, and it made things very, very straightforward in terms of guarding it. All of the attacks that would happen would be network-based and were generally brought about by somebody introducing some software on a floppy disk. For those people who can still remember floppy disks. And we accepted that there was a lower amount of security within the network because we had physical security around it. But assets have increasingly been leaving that network. People started to use laptops. People would work from home more often. People would use their own devices. The rise of the iPad and the tablet brought about a real change in the way that people wanted to access services. SaaS services started to appear. 20 years ago, Salesforce didn't exist. Facebook wasn't around. People have adopted these cloud services because they're easy to get to, easy to use, generally very secure. Now, because of that, attackers have actually been able to shift what they do. And instead of trying to attack a network or attacking a service that they can see, they've started to attack the identities. Using phishing, smishing, whaling, spearfishing, or any other nautical term we can come to around fish, allows an attacker to potentially gain access to the service. Once they're in, they can then move sideways to see if they can gain access to another device, and hopefully, in their view, be able to gain access to a server or to more identities that have higher privileges. The security teams are often overwhelmed by the number of attacks that's taking place, not just from the phishing and credential thefts, but also because they're dealing with denial of service attacks that are coming in on the hardware. They're making sure that they're up to speed and up to date with all of the traditional things they used to do, making sure the firewall's up to date, keeping SolarWinds software up to date, which may or may not have been a mistake. So with all of this, the evolution of what we need to do with security has become really key. As the world transitioned from using mainframes and PCs to data centers and mobile devices, and you could almost see that mainframe to data center correlation and PCs to mobile devices, we're going through that same generational shift that happened in the 1980s, but now happening with mobile devices. It's easy to see that the consolidation of identities is going to happen. People will want one identity to sign into all of the services that they need access to. The introduction of two-factor authentication to combat the weaknesses that we have in passwords. But then that brings in its own issues. If I'm using a smart card for authentication and my device doesn't have a smart card reader, I need to switch back to using that traditional password. With the cloud and Internet of Things, that identity and access management has to incorporate those elements. The hybrid identity, partially on premises, partially in the cloud. The use of smart devices, whether that's reporting on the current ambient temperature inside your data center to your systems management software, or whether it's the performance of a windmill that's actually sitting out in the middle of the Irish Sea so that you can maintain your electrical supply. This Internet of Things is now about using information and making sure things are valid, but we can't always control what that Internet of Things is doing. So the identity and access approach, which originally started off with Windows NT domains back in the days when Novell NetWare 3 was the be-all and end-all for networking, that's changed over time from using an ID and a password inside a domain to using an ID and a password and potentially smart card or other third-party multi-factor authentication against an Active Directory. And that Active Directory and smart card authentication should have enabled us to move away from password weakness and reuse. Although at the time, doing password expiry was still considered to be a very, very good thing. And while some adoption of MFA took place, passwords were it. You would use your password to log onto your device. You'd use the same password to log onto a file share. You may not have seen that you were doing it, but in the background, that single sign-on was happening. The rise of credential theft came around at this point, whether it was the Trojan that sits on your PC and pretends to be a login screen and just takes the ID and password and stores it somewhere. Keyloggers became important. Windows credential editors, Mimikatz became available, allowing people to steal information out of date though it might be, from a device that could still be used. Azure Active Directory in effect has become one of the ways of getting around that by producing an integrated identity provider which is cloud-based but links to your on-premises and can be used to make sure that those users who are identified correctly are using MFA as appropriate, are accessing services that they are allowed to access and no others. By building in support within Windows 10 for TPM chips, using things like Windows Hello, and getting rid of some of the older legacies like SMB1. By doing that, we're able to raise the level of security around where we are. But a lot of this has to do as well with these security perimeters that we've had. When we started networking computers together and started to see these attacks coming in, we knew that we had to adapt some of our controls to protect the computers on the network. And that actually is quite key because we ended up protecting the computers using Intel LAN Desk Manager, using System Center or SMS as it was in the day, allowed us to start locking down the device. Group policies came out of that and allowed us to lock the device even more. But what about when it's not a device we own? With the rise of the internet and the spread of the mobile devices, we end up in a position where actually we can no longer control the device as well as we used to. And instead, what we have to do is deal with the identity. If we know who you are, we know that you work for the business, we know that you're in Department of Finance, then we know pretty much which systems you should have access to. We can control that using an access control policy to make sure that you can see it. Now, we've been saying this for a long time in the identity space, but it's only recently that we've been talking about zero trust and the fact that the perimeter has vanished. Well, is it? Well, let's have a look. Zero trust is not new. In 2004, the Royal Mail, and yes, that's the UK Royal Mail, decided that they were looking at a thing called deperimeterization, which is a wonderful word. They got together and helped out by Cisco in 2004, established the Jericho Forum. And the Jericho Forum was all around getting rid of that perimeter and moving to a more identity and access controlled model. In 2014, they decided that they'd actually done it. The perimeter had gone. We were now able to work whatever we wanted to do from wherever we wanted to do it on whichever device. That perimeter had gone. And instead, we were starting to see a control around identity and access management. So the rise of IAM. At the same time, Microsoft started talking about advocating an assumed breach approach, making sure that you're in a position to mitigate any potential damages that may happen when you have a breach. Please note that's a when, not an if, because we have to use that assume breach. 2016, conditional access came out, which allows us to move forward with that zero trust approach and actually engage better with it. And passwordless, which has been something we've talked about for years, is now at the stage of almost being a valid tool for everybody to use going forward. So attackers now understand that identity is what they need to use to bypass those network controls. And it's more and more important for them to understand and learn how to get that credential from you. They can do that by guessing at your IDs, and IDs are really easy if you know that people tend to use their email address as an ID. So my email address, very obvious, david.guest@thirdspace.net. If someone then does a password spray attack using that as the ID, they may be able eventually to break my password, at which point I would probably need to be advised and change my password. But of course, passwords aren't really enough to protect an identity, particularly with passwords that are being changed on a regular basis. It's human nature that if you have to change something, and change something, you will always make it simpler. So every time you're asking a user to change their password, that password becomes simpler to guess. A good password set in the first place is still difficult to guess, so only change it when you need to. More and more people, more and more auditors are becoming aware of this and actually now removing password expiry as long as the passwords are known good. But these attacks on credentials quite often step around the security because we know that the ID and the password is valid, so we can identify that user, and of course we could choose to trust them. And because these identities are now being used outside of the network, logging onto a shopping site using my work email address and the password that I signed in with this morning, we know is bad practice, but we also know that it happens. Different SaaS providers also have different policies. Some change your password on a regular basis, some don't. Some allow you to not change your password even though it's expired. Some enforce the password change. And we end up in this weird mix where users have different things to remember about different things all the time, which is why we need to explicitly look at the zero trust principles. Who are you? Can you prove it? Can I be sure of who you are because of what you tell me? Obviously, you know your ID. The password, well, that should be secure. But what about the device you're using? Can I use that to validate that you're using a corporate device or a managed device? Or are you somewhere that I don't expect? Are you actually trying to access while you're on holiday? Which, yeah, is something a lot of people do. And how should we actually react to that? When you come in and we've validated you, you should only be able to do the things that your role allows you to. Now, that might mean that you don't have global admin access, but you want to change a CA policy? Well, use just enough access and just in time provisioning to step up to be a security admin. That's enough to do the conditional access change. Don't step up to be global admin because you don't need that. It's not something that's required to do the task that you're trying to do. And assume breach. It's going to happen. Check your network, segment it, make sure that if people are moving from machine to machine, that you know why they're doing it, you're aware of it. Make sure that all of your data is encrypted as it moves around the network. Stop using the legacy protocols, things like SMB1, which are inherently weak, and move forwards with something that's newer and better. So we can use the signals that we get from devices and from users to try and identify whether or not somebody should be granted access. Inbound requests should always be checked. Do I know the user? Do I know the device? Do I know where they're coming from? Have they come in over a VPN from somewhere that I don't recognize? What's the enforcement policy that I have across this, and do they match it? All of these things then come together to allow us to decide whether or not the user should actually go ahead and be granted access. If we can, well, let's get rid of passwords. Let the user sign into their device using a biometric. Many devices today support fingerprints and Windows Hello. Let's use that, identify the user on the device physically so that we know it's them, have the device managed correctly by our device management software so that we can trust it. At that point, do we need a password? We can let the user in and allow them to do correct, validated tasks without that password. If we're not sure, so they've got a laptop, they've used their fingerprint or their facial recognition to sign into it, but this laptop isn't anymore in the UK. They're on holiday and they're coming in from Egypt. Are we still sure it's them? Well, let's just verify that by insisting on a multi-factor authentication because of their location, not just the device. So all of these signals come in. Transition to using that strong authentication instead of the user having a password, whether that's facial, biometric, FIDO2, or something else. Eventually, we would like to think that you can get rid of passwords completely, but that does mean that you will have to have multiple versions of that authentication provider. Now, that could be 2 FIDO keys in case one gets lost or damaged, 2 implementations of the authenticator on 2 different devices. So if one is out of battery, the other one can still be used. Or temporary access pass, which is a pseudo password that has a limited lifespan and can be used by a user to identify themselves and sign in. That's fairly new, but is certainly something that's worth considering. When we're connecting these users and the applications, particularly for cloud, we should be using Azure Active Directory as the identity provider. It can provide authentication services, not just Office 365, but other SaaS applications. So we can link using SAML to things like Salesforce. We can link using OIDC or OAuth to things like Facebook at Work, to AWS. Identifying a user who is a member of a group, that allows them to have a role inside the enterprise application, which allows them to sign in and use that role within that application. So as you can see, the identity here is the key piece. We use Azure Active Directory to validate the identity, to provide the conditional access and multi-factor authentication before allowing the user to go on and access the services. Now we need to provision the accounts into Azure Active Directory. Well, if you've got an AD, well, that's relatively simple. An implementation of Azure AD Connect will synchronize the relevant users up to Azure. It can synchronize the password hashes. We can make sure that authentication only happens in Azure for cloud and happens on premises for those people who are working in the office. But it would be nice to get some automated provisioning. All of our employees are probably in an HR database, so we should link that HR database through to our Active Directory. Have those users provisioned automatically, whether that's coming from Workday or from SuccessFactors through the Azure provisioning service, or from other third-party HR systems using a system like MIM. Once they're in Active Directory, of course, they're still synchronized up to Azure Active Directory through Azure AD Connect. If you don't have an Active Directory, well, that's straightforward. We just go straight from HR to Azure Active Directory through that provisioning engine. We use the information we get from HR to determine departments. We use the job title to determine the role within that department. We use that information to make users member of groups. We use the group information to identify the applications and the role within the applications. And then we're back to allowing the user direct access to the services that they need. And this is all done at the perimeter. As the user is trying to sign in, remembering, of course, that we have a perimeter now around identity and service rather than around the building. So we validate that a user is who they say they are. What is their role, their group, their device, the config, the location, the last sign-in? What do we know about them? But also, what's the device they're using? Are they coming in using a browser? Are they coming in using a thick client? Have they used legacy authentication, modern authentication? Have we required MFA? What is it that we're asking them for? And if we have a look at this as an example, well, a user who is signing in using their normal identity on a Windows device, they're accessing the web services through a corporate proxy. They're in London. They last signed in 5 years ago, five hours ago, sorry. Well, that's great. That's a low risk, and we can allow them access to the office resources. However, if they're coming in with an anonymous config, they're coming in from an unusual location, they device appears to have been compromised or has been used in an attack recently, well, in that case, we can block the access. We can force remediation. If the user's ID and password has been seen in a leaked set of credentials, then we can refuse them access until they've changed their password. This is all done using the conditional access, specifically around the zero trust. So as the user or the partner comes in, we can validate the device that they're coming from. Is it trusted? Is it compliant or not? We can look at where they are, and the latest version of conditional access supports geolocation, not just IP addressing. We can have a look at the application that they're trying to use, and based on that, and based on the 40 terabytes of a machine information that we get on a daily basis into Azure, we can then start to define what is the risk of this particular access. And the session risk, once we've determined that, then tells us what to do. And it's done against the policy that you have defined. And that means that the user could be allowed or blocked. They could have limited access through MCAS, through a broker that stops them downloading files. We can require MFA. If they've just changed their password using the continual access evaluation, we can make sure that they MFA again. Even though they logged in maybe 5 minutes ago, that password reset has now changed things. We can enforce a password reset for user identities that we know have been compromised, have been pawned. We can block any of that legacy authentication. If a user wants to use Thunderbird and access their email, well, that's fine, but they have to configure it with modern authentication, not the older style legacy authentication. And because MCAS and conditional access policies allow us to do things both for on-premises, the Microsoft cloud, and third-party clouds, we can start to be very specific about what access we're going to give and what controls are on that for all of the information sources and all of the users that we're allowing access. But it's quite important that as an administrator, I can actually go in and have a look and see what's been going on. Now, I'll apologize now for the fact that this is probably going to be fairly small on your screen, but here is a list of sign-ins, and we can have a look at interactive sign-ins, non-interactive sign-ins, service principals, managed identities. This just happens to be a list of the sign-ins from proper users, and this is done against my demonstration tenant when I was setting this up. And there are a few things to watch out for, and some of them are on here. For instance, if we zoom in on the conditional access piece, we can see quite often it's not been applied. Why not? What's stopping it being applied? It could be that it's not applied because I'm in a safe location and we've assumed trust on that. It could be that it's not asking for any multi-factor authentication and I'm only providing an ID and a password. Again, that's potentially a problem. If we need to go into specifics, again, we can do that. So here's the log from Cameron White, who's been logging in, and we can start to look at specific instances of this. So this is the login at 3:47:54. We can see it used multi-factor authentication. We can see what the status of that was. It was successful. I had actually applied multi-factor correctly. We can see that the app in this case was a browser. I can't really see what kind of browser it is, but that detail is available. Let's have a look at the authentication detail on this. And we can see that we've done a first factor requirement for the primary authentication, and we've done an MFA, but that it was previously satisfied. Now, what that means is I'm still within the time limit of the original MFA that happened. And that actually happens to be the line underneath. We can also take a look at the conditional access policies that have applied here. And we can see I've got a specific MFA policy against this user. That's obviously not best practice, but for a demonstration, it actually works really nicely. We can also see a number of disabled CA policies. they probably should be removed. Having a disabled policy there is just confusing for support, makes things difficult to understand. We can also look at report only. Now this shows us any conditional access policies that we're currently testing and the effect that that policy would have had on a user. The advantage of that is if we're testing a new policy out and we want to know what to tell the users in terms of what they're going to be seeing, I can be very specific about why and when. And if a user asks, I can point at a specific instance when it would actually have been applied. So what about privilege? Well, privileged accounts, we know they exist, but they should be used sparingly. If you have more than 5 global administrators in your Azure AD, or more than 5 domain admins, schema admins, enterprise admins in your on-premises AD, ask yourselves why. Is that really necessary? 5 is a high number for people who have the total power of your environment. Rather than linking them directly to those privileges, use just in time. Now, Azure Active Directory comes with privileged identity management, which allows a user account to request elevation to the privilege. The request should give them just enough privilege to do their job. If you're modifying a conditional access policy, yes, you can do it as global admin, but you probably should be doing it as security admin instead. Using those Azure roles, you can also potentially link them to software as a service. So you can create a role which would be Salesforce administrator. That, when you log into Salesforce, automatically makes you a Salesforce admin. So by linking all of these together, you should be in a position where nobody is logging in on a regular basis with an account that is automatically a privileged account. There are a lot of roles though inside Azure AD. This is the list as it was a couple of weeks ago, which I've brought across from the portals. And you can see there's a great range from administrators through to readers. Global Reader is a great role to hand out to your service desk so they can go and have a look at how things are. They can see the sign-in logs, they can process that information, they can triage really well. Global Admin, well, that's a different matter. Should your frontline service desk have global admin? I'd suggest probably not. Maybe your third line might have access to it. Implementing PIM, Privileged Identity Management, has to be the best way to put this together. Do it from the top down. Don't try and work out what all the roles are at the bottom end that your first line service desk need, because you're missing the bigger picture, which is controlling that global admin. So start with those highly privileged roles: global admin, security admin, SharePoint admin, Exchange admin. Once you've got them in place, you can work down and say, what other roles do we have in use on a day-to-day basis? Who needs access to them? Do they need approval to get that? And put that into an access matrix of some kind. The access matrix should identify who can have access to a role, who can't have access to a role, and whether or not it needs explicit approval. Understand here that there's probably a degree of trust that you should be putting together. If you trust somebody to be a global admin on request, why do you need to approve each request? If you have a problem, for example, with sign-ins, so somebody signs in order to request global admin in order to fix a problem, but the approver is the one who has the problem signing in, well, they'll never be approved, which means they cannot fix the problem with sign-ins. We're in a catch-22 here. If you grant somebody the permission to elevate as global admin, do you really need that extra level of approval every time they use it? And I think that's something that's definitely worth considering as you go on in this privileged identity management journey. Of course, Now we've got all of these roles, and there's quite a lot of them. It is important to understand which role can perform which activity. Microsoft have got a great document on this. It's called Delegate Roles by Admin Task. The URL's on the screen, so you can copy that down or wait until you get a copy of the presentation or the video. Now, that then details what tasks you would do on a daily basis and how those actually perform and what you need to do it. That then would enable you to assign the specific roles to the specific users. And you can group together these roles. PIM groups have been around now for about 6 months, and a group can be automatically allocated a specific role. So a user joins the group through PIM. Because they're in the group, they get the role automatically. And that should speed things up quite a lot. So with that, I'm going to open this up now for questions. So we've been going for 40 minutes, so we've got 5 minutes left on this. One question that we have had in is talking about zero trust and break glass accounts. And I think this really relates to an area which we discussed at the end, which is privilege. Break glass accounts used specifically when things are broken. So your break glass account should exist in the context in which it's used. So for an AD environment, you would have an on-premises account. For an Azure AD environment, you would have a Azure AD cloud-based account, not synchronized to AD. For your Salesforce environment or Concur or ServiceNow or any of the other cloud environments, they should have a break glass account in that environment. Now, one of the things that we've said is multi-factor authentication is really, really good. Apart from maybe with these break glass accounts, because if there's a problem with Azure MFA, well, how do you make sure that your break glass account can still gain access? But we need to keep the security high. So we would suggest that for those break glass accounts, you have a FIDO key or 2 or 3 available for use for authenticating those users. FIDO keys use an Azure AD service rather than the MFA service to do that validation. So they will still work in the event of an MFA failure. You'll notice I've got 3 or more different breakpoints between these privileged accounts. It's strongly recommended today that an Active Directory privileged account does not have privileges inside an Azure environment, and that an Azure privileged account would not have privileges inside a SaaS environment. And that's so that in the event of an attacker gaining access to one of these services, they can't use it to pivot across to another. We'd also recommend that the naming of privileged accounts is standard. And by standard, I mean doesn't include the word admin or ADM or super or something else that would enable an attacker to identify these privileged accounts. If my account was dguest and my admin account was ADM-dguest, it's relatively straightforward for an attacker to switch and start attacking that privileged account. If, on the other hand, there's dguest and dguest1, well, there could be more than one dguest in the organization. By identifying it in the same way as you'd identify anybody or any name where there are duplicates, it stops the attacker being able to understand it. If you do have an ADM-dguest, I'd like it to be a honey trap, something that you can monitor for attacks on, and if they happen, you know you have an attack in progress and there's something you can do to work that out. So with that, I just got one more question, which is a little bit challenging to read at the moment. So biometrics being used in laptops not being good enough for security challenges. Yeah, so biometrics on a laptop, It's worth pointing out that the biometric on a laptop is the same as using a pin on a laptop. The biometrics are held in the TPM chip, and it's the TPM chip that you're actually using to push forward. There are some concerns about it, not least being the fact that if the TPM chip isn't fully TPM compliant, it could possibly be opened up and attacked, and that's the piece where NCSC are actually started looking on it. So is it worth having it? Well, yes, it probably still is. Is it worth avoiding that and using something like FIDO2? In my opinion, yes. And ideally, use a FIDO2 key that it also includes a biometric, because then we're adding in extra layers without actually increasing the complexity. So with that, having slightly overrun, but I think it was well worthwhile, I'm going to bring this to a close. If you want any more information, then please drop us an email, give us a call. We'll be more than happy to arrange a 30-minute discussion around whatever it is that you're interested in, from the artificial intelligence and the data lakes through to the identity, zero provisioning and mobile device management. So thank you for bearing with me for the past 50 minutes. Have a great day, and thank you for listening.